Hello friends, welcome back to my channel. This is the important topic Dulong and petits law. This law is concerned with the specific heat of the metals. The amount of heat required to rise the temperature of unit mass of a substance through 1 degree Kelvin is known as specific heat. That is Cv equal to dq by dt at constant value. So from first law of thermodynamics, dq equal to du plus pdv. Here volume is constant, so dv equal to 0. So dq equal to du. Substitute here cv equal to du by dt at v.
Net internal energy.
U equal to U lattice plus U electron. Means here the energy is divided as lattice plus the electron. Cv equal to d by dt of U lattice plus d by dt of U electron. So Cv equal to C lattice plus C electron. Here the lattice of electron. Here C lattice equal to energy due to the continuous vibration of atoms about their mean positions. C electron is thermal excitation of electrons. Let us derive an expression for the energy U. That is U equal to half mv square plus half m omega square r square. Here this is the kinetic energy and this energy is the electron energy. So half into mv square into, here I am multiplying with m by m. So plus half m omega square r square. It is u equal to, here this m into m square. So we know p equal to mv. So p square equal to m square v square. So here I am writing p square by 2m plus half m omega square r square. This is the u value, where p is the momentum. According to the Boltzmann distribution law, u bar equal to integral of u into e to the power of minus u by kt into du by integral of e to the power of minus u by kt into du. As u bar is the average energy, we know u value. Before we have derived that u value, substitute here, then we get u bar equal to integral of p integral of r to u value. We know p square by 2m plus half m b the omega square into r square into e to the power of minus p square by 2m kt into e to the power of minus m omega square r square by kt by dp into dr by integral of p integral of r e to the power of minus p square by 2m kt into e to the power of minus m omega square r square by kt into dp dr. Here we have to separate this term p square by 2m into this plus half m omega square r square by m into this. So now I am writing u bar equal to integral of p to the r p square by 2m into this e to the power of minus p square by 2m kt into e to the power of minus m omega square r square by kt into dp dr by this term. Integral of p, integral of r, e to the power of minus p square by 2m kt into e to the power of minus m omega square r square by kt into dp dr plus this term, this into this. So integral of p to integral of r m omega square r square by 2 into e to the power of minus p square by 2m kt e to the power of minus m omega square r square by kt into dp dr by this term. Integral of p, integral of r, e to the power of minus p square by 2m kt into e to the power of minus m omega square r square by kt into dp dr. Here separate the p terms one side and r terms one side, then we get u bar equal to integral of p. P terms are p square by 2m into e to the power of minus p square by 2m kt into dp by integral of p into here also e to the power of minus p square by 2m kt into dp. In the numerator side, r terms are integral of r e to the power of minus m omega square r square by kt into dr. Here numerator side, integral of e to the power of minus m omega square r square by kt into dr plus this side. From this term, integral of p terms also one side, e to the power of minus p square by 2m kt into dp into integral of r terms m omega square r square by 2 into this e to the power of minus m omega square r square by kt into dr by this integral of p into e to the power of minus p square by 2m kt into dp integral of r. R terms are e to the power of minus m omega square r square by kt into dr. Here this term gets cancelled and this gets cancelled. Then we get u bar equal to integral of p square by 2m e to the power of minus p square by 2m kt into dp by integral of P into e to the power of minus P square by 2m kt into dp plus integral of, minus infinity to plus infinity, minus infinity to plus infinity. Here also same, minus infinity to plus infinity, integral of m omega square r square by 2 e to the power of minus m omega square r square by kt into dr by this. Integral of minus infinity to plus infinity e to the power of minus m omega square r square by kt into dr. Here I am assuming p square by 2m kt as a square, m omega square r square by kt as b square. So p square by 2m kt as a square, and this m omega square r square by kt I am taking b square. Substitute here, then we get integral of minus infinity to plus infinity. Here p square by 2m is there. P square by 2m we want. So a square into kt. A square into kt into e to the power of minus a square into dA by integral of minus infinity to plus infinity, this e to the power of minus a square into dA plus integral of minus infinity to plus infinity. Here m omega square r square by 2 is there. Here 2 kt. So m omega square r square by 2 is there. So we want this term. So this into right side, b square into kt. So b square into kt into e to the power of minus b square into dB by integral of minus infinity to plus infinity in e to the power of minus b square into dB. By using standard integrals, a square into e to the power of minus a square we am writing dA as root pi by 2, and this integral of minus infinity to plus infinity e to the power of minus a square dA as root pi. So integral of minus infinity to plus infinity a square e to the power of minus a square dA as root pi by 2, and this integral of minus infinity to plus infinity e to the power of minus a square into dA as root pi. Substitute here, then we get u bar equal to kt into root pi by 2 by root pi plus kt into, similarly for this term also same, kt into root pi by 2 by root pi. So add this, then we get u bar equal to kt. This is the average energy oscillator. This equation is average energy oscillator. Net vibrational energy is u bar equal to n into average energy. This is in one dimensional, but in 3-dimensional, u bar equal to 3 into n into u bar. Here n is the total number of particles. So u bar equal to 3n into, before we have derived u bar equal to 3 kT. So substitute here 3n kT. As we know specific heat from first, Cv equal to du by dt. Yet V. Substitute here the 3n kT into dt. Yet V. So they get 3n k is the constant. dt by dt is 1. So 3n k. Cv equal to 3n k. Here nk I am taking as R, that is 3R. R is the universal gas constant. Universal gas constant. That value R is 8.31 joule per mole inverse and Kelvin inverse. Therefore, Cv equal to 3R. So, this statement is referred as Dulong and petits law. Specific heat of a solid is constant for all temperatures, that is equal to 3R. And Cv is independent of temperature. Means this volume, specific heat of a volume does not independent of temperature. And limitations of Dulong-Petit's law. Limitations of Dulong-Petit's law. It fails to keep Cv of solids at low temperature. Means Cv of solids low temperature దగ్గర explain చేయలేదు. Next, as temperature 0 degree Kelvin, specific heat of a solid approaches to 0. Next, it fails to explain why light elements have less Cv values than heavy elements. Compared to heavy elements have Cv, light elements has less Cv. నా వీడియో మీకు నచ్చినట్లయితే లైక్ చేయండి, షేర్ చేయండి, కమెంట్ చేయండి అండ్ క్లిక్ ది బెల్ ఐకాన్ ఫర్ మోర్ అప్డేట్స్ అండ్ సబ్స్క్రైబ్ చేయండి. థ్యాంక్ యూ.